This section is on linear inequalities. Linear means the variables are degree 1, so the x is going to have no exponent, just the invisible 1. That's what the word linear means. Inequality means not equal to. There are three, really 5 types of inequalities. The not equal to, the less than or equal to, the greater than, and the greater than or equal to. And you want to make sure you have these straight. I always say the less than is the one that kind of looks like an L who fell asleep. People often remember that the big N faces the big number, and that works well when you have numbers. The big N is going to face 5 when I have 3 and 5. But what about when I have X? Which one's the big number now? So you want to learn that less than is the one that looks kind of like an L, and greater than is the one going in the other direction. Those are the inequalities. We graph inequalities on a number line, and as long as we have the variable on the left side, the inequality is kind of like an arrow. So, example, if we want to graph x less than or equal to 4. So here's a number line, and we want to graph x less than or equal to 4. To indicate that it could be equal to 4, I'm going to put a solid dot. The variable x is on the left here, so all the less than ones are going to be here on the left. Really what I'm doing as I color this in is I'm writing a little dot on each number here. 2.99, 2.98, 2.5. All these numbers get their own little dots, and there's millions of them, infinity of them actually. So not to take infinity time to write them all, I just color it in and write a solid line indicating that all those numbers are included. Now the 4 is included, so if I were to say 4 less than or equal to 4, that is a true statement. Okay. If I were to say 4 less than 4, that's a false statement. So in this one I have x less than or equal to 4. 4 would make it true, so that's why I want 4 to be a solid dot. If I take that equal sign away and just make it x less than 4, I no longer want to include the 4, so I'm going to use an open circle, indicating that I want every number close to 4, right up to it, but not including it. In other words, 3.999999, as many 9s as you want, is included, but the 4 itself is not included. I cannot put a dot on the 3 and then go to the left, because then I would be leaving out all these fractions in here between 3 and 4. So I want to write it in that way. Okay, if I was going to do greater than or equal, I would do the same thing, a solid dot to the right, and greater than an open dot to the right. Okay, now how do I solve these things? You solve them just like lines. So if I have x plus 2 greater than 5, I want to solve and graph. The only difference is when you divide by a negative, you have to change the direction of the inequality. You multiply or divide by a negative. Multiply or divide. Mostly what we're going to be doing is dividing by a negative. Change the direction of the inequality. Sometimes people call that the sense of the inequality. That's the only difference in solving an equal sign. So in this case, I want to get the x term alone. So I'm going to subtract 3 from both sides, giving me 3x plus nothing, greater than 2. and then I'm going to divide both sides by 3. 3 is a positive number, so this is going to stay the same. So x is greater than 2/3. Okay, let's graph it. To graph it, where's 2/3 at? 2/3 is between 0 and 1. It's not included, so I'm just going to make a big circle. Make sure I hit it. And I want everything that's greater than in this direction. Okay. Let's try another one. Let's try 4 minus 2x is greater than or equal to 10. Okay. I want to get the x term alone, so I'm going to subtract 4 from both sides. This leaves me nothing. Minus 2x greater than or equal to 6. Here's that last step. Look what I'm dividing by. Whoops, not 2x, just negative 2. I'm dividing by a negative. So that means this is going to have to turn around. So these are going to cancel, giving me 1x. This is going to turn around and become a less than or equal. 6 divided by negative 2 is negative 3. And how would I graph that? Negative 3 is included. It's going to be a solid dot. Hard to get centered here. And everything to the left. Let's think a minute about why that works. Think about the number line. And when I have the number line, move it down here. I have the number line. If I have, for example, 3 and 5, 3 is less than 5. But look over here. Negative 5, is less than negative 3. So if I wanted to multiply both sides of this by negative 1, what would I get? Negative 3 greater than negative 5. Because these numbers on the left, these negative numbers, appear to be going backwards from these numbers. So when I multiply by a negative, I need to go in the other direction. And let's look at another example. 3x plus 5 less than or equal to negative 7. And we'll solve and graph this. Solve and graph. So I'm going to subtract 5 from both sides. This is 0. So 3x is less than or equal to negative 12. Dividing both sides by 3, notice I am not dividing by a negative. My answer is turning out to be negative, but I'm not dividing by a negative. I don't look at the answer. I look at this part under here that I'm dividing by. This part is positive, so the direction of my inequality is going to stay the same. So when I graph it, I want to include the negative 4. It's going to be a solid dot, and do everything to the left. Okay, let's do a string of inequalities. Let's say, before we do that, we've got these people here, Fred and Jan. Todd's arms aren't coming very well. There's Todd. Okay, how would we describe where Jan is? We probably wouldn't say Fred is to the left of Jan, who's to the left of Todd. What would we say? We'd say Jan is between Fred and Todd. So we're going to do the same thing when we look at numbers. So when I have 3 less than x less than 5, how am I going to say this? X is between 3 and 5. Now if we put equal signs under there, we might include the words including 3, including 5. Okay. So when we see a string like this, we're going to say between. Notice we can also say here that x is greater than 3 and x is less than 5. What numbers are greater than 3 and less than 5? All the numbers that are also in between 3 and 5. So how would we graph these particular ones? If they are between 3 and 5, here's 3 not included, 5 not included, we mean these. Notice these numbers in here are greater than 3 and they're also at the same time less than 5. We can solve equations like these by doing the same thing to all 3 pieces. So for example, let's suppose we have -2 less than or equal to x plus 1 less than 3. Notice it always has to be true that this number is less than this number. Otherwise it wouldn't make any sense because this couldn't be in between them. Okay, let's focus on this x. How are we going to get it alone? We're going to subtract 1. So we have to subtract 1 from all 3 sides. I guess we can't call them sides. All 3 parts. So that's going to give me -3 less than or equal to x plus 0, which is just x, less than 2. So when I go to graph that, the -3 is included, the 2 is not, and I want everything that's in between. Okay. Maybe give you one more and let you try it. And then we have one last type to look at. -5 less than 2x plus 3 less than or equal to 5. Okay. So first thing we should do, trying to get the x term alone. So I'm going to subtract 3 from all 3 parts, giving me -8 less than 2x less than or equal to 2. One last step, divide everything by 2. Notice the thing I'm dividing by is positive, so these are going to stay in the same direction. And 2 divided by 2 is 1, so x is in between -4 and 1, including 1. So I'm not including -4. I am including 1, so it's going to be solid. And I want everything in between. And that includes that fraction over here, -3.999, 0.999. Okay, what if we have the word or instead of the word and? X is less than -3 or x is greater than or equal to 2. Or means one of the other or both, typically, when we use it in English. So not necessarily both, but possibly. So we want all the numbers that are less than -3. That's all these numbers. Or instead the numbers could be greater than or equal to 2. So when you have an or, you have the 2 going in the opposite direction. When you have the and, that's when you want the numbers in between. Okay, that is the last topic in homework 3. So you should be able to do all of the homework 3 problems.